Hello everybody. Today I can prepare for my polynomial graphs remainder theorem test by practicing. That's how we prepare for a math test. We practice. Let's get to it. Consider the end behavior description below. So, you need to know what end behavior means. As x approaches negative infinity, that means as I go to the left. F of x approaches infinity, that means up. As x approaches positive infinity, that means that as I look to the right, f of x approaches negative infinity, that's down. So, I have two graphs, I have two equations. For the equations, you can use the calculator, but you should know that since this is even, it's U-shaped, and since this is a positive leading coefficient, it opens upward, so I know that it's going to look like this. This has an odd leading coefficient, so it's chair-shaped. It's negative, so it opens down, so it looks like this. And again, you could use the calculator, but I'd rather you just know. So now let's look. It's got to, as it goes left, it's got to go up. This one checks that. This one goes down to the left. This one goes up to the left. This one goes down to the left. As we go to the right, it's got to go down. This one's going up and to the right. That's wrong. This one's going down and to the right. That's right. That's it. Know what your end behavior means. As x approaches negative infinity is left. As x approaches positive infinity is right. F of x, positive infinity is up, and negative infinity is down. Very important. To write the equation of a polynomial graph, I need to know the factors. In order to get the factors, I need the zeros. So, the zeros hit the x-axis. The factors don't. So if the zero is negative c, then the opposite of that, x plus c, is a factor. If negative b is a 0, x plus b is a factor. If positive a is a 0, x minus a is a factor. We check for double roots. This is a single root. It passes through. This one passes through. This one bounces off. Therefore, it's a double root. Therefore, that factor must get a squared. It opens up at the end, so it should have a positive leading coefficient. I carefully look at the choices. The x plus c is squared, x plus b, x minus a, positive leading coefficient. That's your answer. The zeros hit the x-axis, the factors are x plus or x minus, and you change the sign going back and forth. Real zeros hit the x-axis. Imaginary zeros don't. Let me just make it a little bit smaller because this is just wildly big. So what you need to know for a couple lessons here, this one song kind of takes care of two concepts. Real zeros hit the x-axis, imaginary zeros don't. Real zeros hit the x-axis, imaginary zeros don't hit the x-axis. So it wants to know which of these has imaginary roots or imaginary zeros. So imaginary zeros don't hit the x-axis. This one does not hit the x-axis. This hits there and there. This hits there. This hits there and there. For another question coming up, this song also applies. Understand that the zeros are where the graph hits the x-axis. Hits the x-axis. Hits the x-axis. All right, let's move on. To determine if something's a factor, I need to find the remainder using remainder theorem. So I'm substituting the opposite of what I'm dividing by in for x. You can do this with storing, you can do it without storing, but either way, show the work on paper, what you're substituting in. I'll do it without storing, and I'll do it with storing later in the multiple choice version of it. So 6 to the third minus 6 times 6 squared plus 4 times 6 minus 1 is 23. So that's the remainder. Something is a factor if it goes in evenly, meaning it has a remainder of 0. So if the remainder is 0, it's a factor. If it's anything else, it's not. Since the remainder is 23, no, it's not a factor because the remainder is not 0. If the remainder is 0, it's a factor. If it's anything else, then it's not. So if we do a multiple choice version of this, it's the same thing. Which binomial is not a factor? Well, let's go through each choice and let's see which one has a remainder of 0. So for choice 1, I would substitute positive 11 in. For choice 2, I would substitute negative 2. For choice 3, I would substitute negative 6. For choice 4, I would substitute negative 3. I don't have to show work since it's multiple choice. So I'm going to do this one with storing. It's much easier. So I'm going to, whatever I'm substituting in, that's what I'm going to store. I'm going to store 11 as x. Then I just type in x cubed minus 6x squared minus 49x minus 66. And I get 0. So that one is a factor because the remainder is 0. It says which one's not a factor. Either way, I like to go through all 4 choices. So now if I want to substitute negative 2 in, I can just store negative 2 and then just copy and paste what I'm subbing it into. Again, that's the benefit of storing. 0. So that one is a factor. Choice 3, negative 6. Negative 6, store as x. Copy and paste the expression that I'm substituting into. Negative 204, that's not 0. I think we've got a winner, but let's take a look at negative 3, store as x. And let's copy and paste the expression one more time. And 0. 0 means that it's a factor. Which one's not a factor? Choice 3. This is based on that. If x plus 4 is a factor, then I know that negative 4 is a 0. And if negative 4 is a 0, then negative 4 comma 0 is a point on the graph. So I'm going to replace p of x or y with 0, and I'm going to replace the x's with negative 4s. Why did I choose to do them with such big numbers? Use the calculator as needed. I can't type the whole thing in, but I can type each term in. 6 times negative 4 cubed is negative 384. Positive 31 times negative 4 squared, so 31 negative 4 squared is 496. Positive k times negative 4 is minus 4k. Minus 12 equals 0. Combine like terms. I've got negative 384 plus 496 minus 12 is 100. So I have 0 equals negative 4k plus 100. Negative 100 equals negative 4k. Divide by negative 4, divide by negative 4. 25 equals k. And that's it. So if they tell you the factor, then you know the 0. You put that 0 in for your x value, and your y value is 0. Sketch the graph of a polynomial function whose factors are. So here's where students get confused. Do I switch the sign or do I not switch the sign? So the answer is real zeros hit the x-axis. The zeros hit the x-axis. If it says that the 0 is 1, then it hits the x-axis at 1. Factors don't. Factors don't hit the x-axis. So if the factor is x plus 1, x plus 1 doesn't hit the x-axis. The 0 is negative 1. The 0 is positive 4. The 0 is negative 2. Zeros hit the x-axis. Factors don't. If I look at 14, for 14, it says the zeros are -5. So -5 is where it hits the x-axis. -2 is where it hits the x-axis. +6 is where it hits the x-axis because the zeros hit the x-axis. This one did not give you the zeros, it gave you the factors, so you have to switch the sign to get the zeros. So now, the zeros hit the x-axis, -1, -2, +4. Are there any double roots? Yes, the 4 is a double root. So I'm going to put a little circle there, so when I draw this, when I sketch it, I can make sure I bounce off. It doesn't specify if it's positive or negative, so that doesn't matter. Pass through, bounce off, arrows, arrows. If yours is pointing up in both directions, that's fine as well. Zeros hit the x-axis, and be careful for double roots. A couple of old topics going to be in the exam. The only reason I put an old topic on the exam if it's going to be very important moving forward, which these definitely are. Mr. X squared, he wants to party. Before he can party, all of his friends have to come over. We're good. All of his friends are over. Party time, bubbles, factoring. Factor GCF dots. Is there a GCF? No. 3 terms, trinomial. Tricky trinomial? Yes. Build the bridge, don't forget to pay the toll. X squared minus 4x minus 12. Factor normally, x and x. First sign comes down, negative and a negative is a positive, multiplies to 12. Subtracts to 4. Bigger number goes first. Pay the toll. If it divides nicely, divide it. If not, put the denominator in front. Now we set each factor equal to 0. We set x minus 2 equal to 0. We set 3x plus 2 equal to 0. And we solve each of them. X equals 2. Minus 2 minus 2. 3x equals -2 over 3 over 3. X equals -2/3. 15 and 16 are both tricky trinomials, so I'm trying to tell you that you're going to have to solve a polynomial equation with a tricky trinomial. 17 and 18 are both 4 terms, so you're going to have to do that process, which we'll do now. Mr. X cubed, he wants to party. Before he can party, all of his friends have to come over. Are all of his friends over? No. Minus 4x minus 24 minus 4x minus 24. X cubed plus 6x squared minus 4x minus 24 equals 0. Party time, bubbles, factoring. Is there a GCF? No. How many terms? 4. Grouping. I group the first 2 and the last 2. I find the GCF of each group. If there's a minus in front of a group, I pull a negative out. X squared, x plus 6 minus 4x plus 6 equals 0. That's step 1 of grouping. Step 2 is to combine your coefficients, x squared minus 4. Keep the like term, x plus 6 equals 0. Can I factor further? Yes. I have difference of 2 squares, 2 sets of parentheses, plus and minus, square root of each, x and x, 2 and 2. The other one comes down. Set each factor equal to 0. Set x plus 2 equal to 0. X minus 2 equal to 0. X plus 6 equal to 0. Solve each of them. X equals -6 plus 2 plus 2. X equals 2. Minus 2 minus 2. X equals -2. Boom, boom. So you're going to have a polynomial equation with grouping on your test. You're going to have a polynomial equation with a tricky trinomial on your test. Both of these are throwbacks to the first unit. You're going to have to sketch a polynomial equation where I either give you the factors or the zeros. You're going to have to find k given a factor by subbing in the opposite, by subbing in the 0 for x and 0 for y. You're going to have to determine multiple choice, which binomial is or is not a factor, using remainder theorem. You're going to have to do an open response using remainder theorem. You're going to have to identify which graph has or doesn't have imaginary roots. Real zeros hit the x-axis. Imaginary zeros don't hit the x-axis. You're going to have to write the equation of a polynomial graph by changing the sign, going from zeros to factors, and watching out for double roots. And you're going to have to answer a question based on end behavior. You have to understand what end behavior is, and from there match it up to the appropriate graph. Practice, practice, then practice some more. If you can do these 9 different types of questions or 8 different types of questions, then you should get 100. That's it. Practice. Have a great day.